We have two types of chain reactions, controlled reactions and uncontrolled reactions. Now, controlled reactions is a chain of nuclear reactions that take place under controlled conditions. For example, in power plants, they must control the reactions, and usually with heavy water, so that it doesn't produce huge amounts of energy that would cause an explosion. Now, the uncontrolled reaction is vice versa. It's a chain of nuclear reactions that take place under no controlled conditions. These reactions produce huge amount of energy and is the process used in atomic bombs. Uranium-235 is the only atom that can perform fission. Although uranium has 8 isotopes, which are uranium-233, uranium-239, uranium-235 is the most active of them all and the most unstable. During uranium fission, a slow neutron enters the nucleus of uranium-235, which causes it to be highly unstable and become uranium-236, which has a life of few seconds. When it changes the shape of the nucleus into a dumbbell, Coulomb forces work to break the nucleus into two. The nucleus releases an energy of 200 million electron volt, which is because of the binding energy that kept the nucleus intact. 20 pairs of fragments are possible to be produced by this process. Now let's talk about fusion. Fusion occurs when two light atoms bond together to form a heavier one. The total mass of the product atom won't be equal to the total mass of the reactant atoms, and that's because some of the mass of the reactant atoms are converted into energy after binding. This is described by Einstein's famous equation, which is E=mc². Fusion only happens on the Sun, because it needs high pressure and high temperature to occur. Fusion reaction releases much more energy than fission reactions do. Also, fusion reactions cannot be controlled and have no radioactive byproducts. So now let's put nuclear fission and nuclear fusion side to side and compare them. Fission is a splitting of a large atom into two or more smaller ones, while fusing is the fusing of two or more lighter atoms into a larger and a heavier one. Fission doesn't really occur in nature, while fusion occurs in stars such as the Sun. In fission, the products have less mass than the reactants. When nuclear fission, the product has a greater mass than the reactants. It takes little energy to split the two atoms in a fission reaction, while it takes extremely high energy and pressure to bring two or more protons close enough in a nuclear fusion. In nuclear fission, the energy released is millions times greater than the release in chemical reactions, while in fusion, the energy released in fusion is 3 or more times greater than the energy released by fission. Although they have so many differences, both nuclear fission and nuclear fusion have similarities. Both of them use the energy stored in atomic particles. And both of them are processes that aim to produce energy. And also both of them are reactions that are suitable for making nuclear bombs. Of course, with no doubt, most of us have heard about the atomic bomb that struck Hiroshima, and was a tragedy noted in history. But now, knowing that there are two types of nuclear bombs, do you know which one was it? Was it fission or was it fusion? And what's the difference between these two? Let's check it out together. Now, of course, if you have done some research beforehand, you would know that the bomb was a fission bomb, which is a good thing, you could say, in one part, not by that degrading the event itself, but knowing that a fusion bomb, or hydrogen bomb as it is called, would have caused much more damage than it already did. Alright, so now let's go to the differences. First, atomic bombs, as we said, uses fission, while hydrogen bombs, as we said too, uses fusion. Second, hydrogen bombs are 1,000 times stronger and more destructive than atomic bombs. Third, atomic bombs use uranium-235 or plutonium, while hydrogen bombs use deuterium or tritium. And that's our wrap up with Superatom and her adventure with nuclear physics. Hope you enjoyed and of course learned something new. Have a good day, see you next time with more adventures.